Good morning and welcome to the 54th Lunar and Planetary Science Conference. This is the third press conference of the week, and we're delighted to have you here and all of you who are online. I'm Suraya Faruqi, and I'm the Director of Communications at University's Space Research Association, which is sponsoring the press conference, and my colleague, Julie Tegelski from LPI, is assisting me in this press conference. There are just a couple of housekeeping items. The cadence of questions will be as follows. We will take 2 questions from the room and then 2 questions online. And that is the cadence that we'll continue to follow right throughout. Julie will be relaying the questions from the online reporters, and I will be taking the questions from the room. Now, as you all know, the Stratospheric Observatory for Infrared Astronomy had made extensive observations on the distribution of water on the lunar surface during its last year of observation. And the panelists today will be speaking on the topic of molecular water in the lunar far south using 6-Micron Spectral imaging. So I'd like to introduce the panelists now. Dr. Bill Reach from University Space Research Association and Director of SOFIA. Dr. Casey Honeyball, researcher at University of Maryland, whose graduate thesis focused on the finding of water on the sunlit surface of the moon with SOFIA. And Dr. Honeyball will be joining us virtually. And Dr. Paul Lucy, professor of geophysics and planetology at the University of Hawaii. So with that, I'm going to turn it over to Dr. Bill Reach to start the presentation.
Okay, thank you, Suraya. So we're glad to share our latest results with you today. Here's our names again and the picture of our observatory. So first, let me just show a video that shows where we observed and gives you a preview of the results themselves. So there's an image of the full moon. We did our project while observing at the full moon, and we observed this region that's colored in the bottom. And then the new results, which we're going to talk about, are the details of this, the structure of this, the fact that we see a tracer of water on the surface over this patch, and what do those structures mean? All right. So the video will just be another second, and now it's almost reached the South Pole itself, where data start to peter out because you can't see the far side from here. Okay. So what's the purpose of this work, and what were our findings? There's an image of the full moon again, showing in blue the region that we observed, and in green a little area that I want to highlight centered on one crater. Then that green area is shown in a little blow up that shows a particular crater that has a nice central peak mountain in it. And the main thing that we see that and you can understand by looking at this picture is that the water distribution is associated with the surface features, but it doesn't just trace their outline. So what you see in this picture in the visible light image, the one that has the green box around it, you can see a crater. You can see the shaded northern rim of the crater. Then if you look to the left, which is the water image that we made with SOFIA, you can see that the water distribution is actually in that shaded area. So it's not on the rim of the crater, it's under it. And then for the central peak mountain, which is right in the middle, pretty much right in the middle of the crater, you can see in the water image, you see a dark ellipse and then a bright ellipse right under it. And those are the sunny and shady sides of that peak. And there's more water on the shady side, and there's actually less than the surroundings on the sunny side. An easy way to understand this, although it has nothing to do with the physical processes that are happening on the moon, is the way that the north side of mountains in the northern hemisphere collects more snow, and the south side it tends to be bare, like in the picture that's shown here, where you see the bare rocky face that's facing the sun. So we think that for this central peak, which is a tall mountain in the middle of the crater, that we're seeing this effect, a north face effect. But again, that's just an analogy. It's not actually snow. All right. Now I'm going to turn it over to Casey to talk about how we did this work.
Thanks so much, Bill. So to make these observations, we use SOFIA, the Stratospheric Observatory for Infrared Astronomy. SOFIA provided the only opportunity to observe the moon at a wavelength of 6 microns. This wavelength is uniquely due to the water molecule. There have, however, been previous observations of a water-related molecule on the moon. Observations from the Moon Mineralogy Mapper on the Chandrayaan-1 spacecraft detected a 3-micron band in 2009. This 3-micron wavelength reveals the presence of the hydrogen-oxygen bond, which could be due to the water molecule itself or its cousin hydroxyl. These 3-micron measurements therefore could not definitively determine if water was present on the surface of the moon. But fortunately, water has a unique fingerprint at 6 microns that cannot be confused with hydroxyl. So to look for water at 6 microns, we could not use ground-based telescopes due to water in the Earth's atmosphere blocking all of the signal from the moon. SOFIA, however, flew above 99.9% of Earth's atmospheric water, allowing us to detect lunar water. There were also no space-based telescopes capable of this measurement for the moon, making our SOFIA observations unique. Next slide, please. So with SOFIA, we originally observed single locations that provided little spatial information about the distribution of water on the surface of the moon. However, as we continued observing, we continued to develop techniques that allowed us to map water on the surface with SOFIA. These maps were made at a 5-kilometer spatial resolution, and the image on the left was acquired by the Lunar Reconnaissance Orbiter, with the blue outlining showing where our SOFIA observations that we are reporting here were obtained. As you can see, we are also identifying some prominent craters. The image on the right is showing our full lunar water map from SOFIA observations. The areas that show up as blue indicate higher water abundances. And you can see from this map that SOFIA is able to resolve small geologic features like the central peak of Mortis crater on the left side of this map. And this is the crater that Bill was referring to in the first 2 slides. Okay, now I'm going to pass it over to Dr. Paul Lucy.
So the origin of water and how it moves on the lunar surface and how it can reach the lunar poles is, this is an area of active research going on even at this conference. So water can be, that we see on the surface can come from ancient water that diffuses up from the interior. It can be actually created by chemical processes in the lunar surface using hydrogen from the solar wind and oxygen from lunar molecules, or it can be introduced by comets, asteroids, or small meteorites that can contain water. One of the outstanding questions about the moon is how water that's introduced, how does it move around on the lunar surface? And this is an active area of research to understand if water can propagate through the lunar exosphere, that is the very tenuous lunar atmosphere, and ultimately arrive to form ice deposits at the lunar poles. The contribution we've seen from SOFIA is that there is a correlation between the abundance of water and the temperature of the surface. The sort of conundrum we have is that the temperatures we're seeing are fairly high. So the water that it should be migrating very rapidly in the surface, and it should be difficult to detect. So we think there's an interaction between meteorites that can freeze the water in little blebs of impact glass, and so we could freeze in this pattern that we're seeing on this north face effect. This is very important to understand if this transport of water through the exosphere is available to stock the ice deposits at the poles, and whether or not those deposits might be sustainable. And back to you, Bill.
Okay, thanks, Paul. So just to summarize and bring some conclusion to this, one thing we did with this work was we do confirm the presence of water and not just hydroxyl in a widespread distribution across a large patch of near the southern hemisphere, a large part of the southern hemisphere. All right, and we also, for the first time, find a detailed map of its structure and its association with lunar surface features like deep crater rims and mountains with steep slopes and a clear sun-facing and shaded side. So those are the new things. And I will say that SOFIA, the observatory that you see there, the giant 747 plane. So we did these observations last year. Last observations with that observatory were in the end of September, and now we're in the process of making an archive that will last for years and contain the results. We're still analyzing those final results now. We hope to have the results of this project, and we observed a lot of regions across the lunar surface by the end of the year. Okay, Soraya, that's it.
Thank you so much. So are there any questions? I do have one, and so I wanted to ask you, what is the future? Are you planning to do some more observations using some other observatories regarding the water and the moon?
Yes, well, so we have our SOFIA data that we're going to be working on, and then Paul or Casey, you should talk about the other.
Yeah, the SOFIA observations and detections of water have spawned a lot of interest, and what people are planning for future missions is including instruments that will measure in this wavelength region. This was not on the agenda before the SOFIA detections, but there's a lot of interest in doing that from several groups that are proposing future missions to the moon.
And ongoing ground-based observations to try and see things in more detail as well. Yeah.
So would there be a difference between the ground-based observations versus the SOFIA observations?
Well, I mean, we can, from the ground, we're limited to wavelengths other than the 6-micron water molecule. The other major wavelength region is near 3 microns, and that's a combination of the water molecule or its cousin hydroxyl, which is a active radical, and it attaches to other materials. So it can't migrate across the surface. So, but the 3 micron observations are very useful, but they can't distinguish these two. What's unique about these SOFIA and some future 6 micron observations that they're uniquely sensitive to the water molecule.
Just a little more on that is that there is also the NASA Trailblazer mission, which is coming up very soon. We have found out it's going to launch sooner than planned. It's rare that things go earlier than later, and we'll be trying to work with them to provide some complementary information to that mission, and that will also be trying to see the detailed distribution of water on the surface.
Thank you.
Okay, I think we're going to open it up now to those watching on Zoom. Virtual participants can use the raise hand feature in the Zoom controls to ask a question, and you'll be prompted to unmute yourself. So please state your name and affiliation first, followed by your question. Are there any questions from our virtual participants?
In case anyone's listening, so while you're the paper, there is a paper that's being published. The preprint is available, and there's a press release coming out at 11:45 that will have the details that you'll need to write your article.
The press release should be out at about. The press release should be out within 5 minutes right now.
Okay.
And so you'll have all the details with that. Anything else you had?
No, that's going to be on nasa.gov and USRA.
Yes, that's going at nasa.gov.
Yeah.
And it's also going across the wire. So that's there, and it'll also be across USRA.
Yeah, and we're available for questions. Paul and I and our other co-author, Alicia Arredondo, are here at the conference, and Casey, her contact information is available, and talk to any of us.
Okay, thank you very much. I really appreciate that. And I'd like to thank the panelists for a really great presentation. Really appreciate your time and energy to have prepared for all this. Thank you again. Okay.